today what we're going to do is we're going to look at the properties of numbers and operations. So properties of numbers and operations. Let me just split this out like that. Change the color and then move it up a little bit. Right. And the objective for today, hopefully the title conveys it. So let's say objective. The objective for today is to use properties of numbers and operations in computational tasks. Right, so we're going to look at the several properties and how they apply, and when we go further in on math, you're going to see these properties coming back up. We're not going to do any kind of problems or questions related to it now, but hopefully with the definitions you should understand where they are being applied when we're solving problems. Right, so let's start with the first one, which is closure. So closure, and the definition of closure is as follows. It states, this property states that performing an operation on any two numbers in a set will always result in a number that is also in the same set. Right? So if we're talking about closure and we look at something, one of the operations such as let's say addition, put this in yellow, so let's say addition, and we try to establish closure for addition, we would see that let's put this in this color. We'll see that the sum of any two real numbers is always a real number. And just so that you could get a little bit of math understanding of this, let's write it like this. So if A and B are members of the set of real numbers, then for closure, A plus B will belong to the set of real numbers as well. Right? So that's closure for addition. There's also closure for multiplication. So let's establish one for multiplication. And for the multiplication, the product of any two real numbers is always a real number. Put that in white so I can do it in a little bit of a math statement as well. And it will say that if A and B are members of, let me write that a little bit better, are members of the set of real numbers, then A times B will also be a member of the set of real numbers. The next property that we have to talk about is associative law, or basically associativity. Associativity. Let me write that up. Associativity. Right? So the associative property states that the way numbers are grouped in an operation does not change the result. So what does that mean for addition? For addition, that means that, just write it down, so addition. So for addition, that means that, let's say for instance, we have A plus B plus C. We're going to see that with associativity or the associative property, we can do it however we wish. We can group whichever two real numbers that we want to work with, or whichever two numbers we want to work with, and it will be the same. So if I group A plus B and then I add that result to C, I will get the same result as if I have A and then I add it to B plus C. So if I solve this first and then take the result and add it to A, or I solve this pair first and then take that result and add it to C, it does not matter. I will be able to get the exact same result. The next one that we're going to look at is multiplication. So let's do this one here. So multiplication. Actually, this one was what, yellow before? Okay, let me just put this as yellow. I'll put this one as yellow as well. Right? For multiplication, it means the exact same thing. If I have three terms multiplying by each other, so if I have A times B times C, then I can take A times B, then take that result and times it with C, or I can take A and times it with the result of B times C. Again, I can work this out and then take that result and multiply it here, or I can work this out and take that result and multiply it here. It gives me the exact same answer. So that's the associative property, right? I know the word is a little bit challenging, so I just usually refer to it as the grouping property when I have to say it. So the grouping property for me, or the associative property, is just a matter that says if you group the numbers however you wish, they work just the same, right? So you can group the first two, you can group the second two, it doesn't matter. All right, let's go on to the next one, which is commutativity. And this is another word, so commutative property, right? So we're going to talk about commutativity. And this is the commutative property states that the order of numbers in an operation does not change the result, right? So when I say commutative, I usually say the move-in property, right? The move-in property. So when we look at it for addition, let me just put addition here. So addition, when we look at it for addition, it would mean that if I have a number A adding to a number B, then it's the same as if I take a number B and add it to the number A. Now, back to the associative property here. So with this, you can also see that if I wish, I can move things around and then associate it that way. So I can move this around and I can say A plus C plus B, and then I can group this together and solve it. Or I can just simply say A plus C plus B. I can group that together and solve it. So this is like if you're using a combination of two of them. Let me give you an example of the numbers. So let's say, for example, we decide that we want to have 2 plus 3 plus 4. I will always get the same result. So 2 and 3 is 5, 5 and 4 is going to be 9. Even if I decide to say, okay, well, 2 plus 4 plus 3, I will always get 9. Or if I decide to say 4 plus 3 plus 2, it's still 9. Right? So that's showing that if we associate it in different groups, or even if we move them around, addition will tend to give you the exact same result. So that's basically what we're talking about when we talk about associative and commutative with respect to addition. And similarly, it has the same effect when you're looking at something for multiplication. So let's say we have multiplication. So if multiplication is commutative, which it is, we're going to have something like this. If I say A times B, it's the same as saying B times A. And you can think about this in terms of 2 times 3. 2 times 3 is the same as 3 times 2, which means it's 6. You're getting 6 both ways, All right, so that's the commutative law, right? Then we go on from the commutative, sorry, not commutative law, commutative property. Then we go on to the next property, which is the identity property. So let me just put this here, identity property. So identity, right? So the identity property, this property states that there is a number which when used in an operation with any other number leaves the other number unchanged. All right, so let's say, for example, we're looking at something like addition again. All right, let's go with addition. So here, addition, so addition. And let's say, for instance, we want to find the number which, when added to any other number, would result in the same thing. So let me just put a little definition right here. So with respect to addition, you know what? Let me just change this here. This is additive identity, right? The additive identity. Let's put a little definition here. So we say the additive identity is 0. All right, let me just put that in quotes, 0, because any number plus 0 equals the number itself. So in other words, any number, if A is any number that belongs to the set of real numbers, and we add it to something like 0, we'll always get back A. And this here, you can think of something like, okay, let's say 2 plus 0, we get 2. 3 plus 0, we get 3. 4 plus 0, we get 4. That's the additive identity, right? So 0 is the additive identity, because anything that we add 0 to, we always get this. We'll always get back the same numbers we add into 0, right? Similarly, we have something called the multiplicative identity. We just put that there. Multiplicative identity. And similar to the additive identity, we can say that the multiplicative identity is 1 because any number times 1 equals the number itself, right? So anything that we take and we add to 1, we'll always get back that number. So let's say we have something like A times 1, we'll get back A. So examples of that is like 1 times 1 is equal to 1, 2 times 1 is equal to 2, 3 times 1 is equal to 3. So notice again, what we're doing is we have a number and we're multiplying it by the identity in each case, and we're able to get back the exact same number that we multiplied to the identity in the first place. Right? This multiplicative identity and this additive identity is something that we will use or apply when we're doing algebra, and you'll see more of that later on. Let's go on to the next property now, which is the inverse property. Well, let's see, inverses here. So inverses, right? Let's just do inverse property actually. That works better. Right? So the inverse property states that for every number there is another, let me just put this in the next line. There is another number which, when combined with the original, which when compared to the original number would tend to give original number in an operation results in the identity element. Well, let's just say identity of the operation. Yeah, that better. All right, so inverse property states that for every number, there is another number which, when combined with the original number in an operation, results in the identity of the operation. All right, so let's say, for example, we're looking at addition. We know that the identity for addition is 0. So if my number is a, then the inverse of a is going to be negative a. We just write that out. All right, so let's say, you know what, let me put a title right here. All right, so we have the additive inverse. All right, yeah, that works. All right, so additive inverse. Let's say, for instance, we have a and we add it to negative a. We know that we'll get 0. So that means that negative a is the inverse of a. So, well, the additive inverse of a. So like, let's say, for example, you have 2 plus negative 2. This here is 0 because you combine, you work this out. When you simplify that out, plus and minus is a minus, so it's 2 minus 2, and you get your 0 at the end. All right, so let me just put a little note for that, small little note, nothing major. All right, so the additive inverse of a number is its negative. All right, so additive inverse of a number is its negative. So you can see right away, additive inverse of 2 will be negative 2. All right, and then we go on to a multiplicative inverse. Multiplicative inverse. Right? Same. Let me do a quick definition here. So the multiplicative inverse of a number is its reciprocal. In other words, the flip. Let me just put that there in words. In other words, the flip. You know what? There. So the flip. All right. So let's say, for instance, we have a. The multiplicative inverse of a is going to be 1 over a. So the inverse of a. And when we multiply these two, a's will cancel off because this is a over 1, and we get 1 as the result. Now, this is only true for a that is not equal to 0. What does that mean? We can't have 0 over 1. We can't multiply 0 over 1 by the multiplicative inverse, which is 1 over 0. This here is 0. And this here, and I'll put it in red, this here is undefined. All right? And if you decide to do that on your calculator, you would see for yourself that what you're going to get is an error. All right? So this here would not give you the result of 1. The next property that we have to talk about is the distributive property. So let me just put that here. Distributive, so we say distributivity. Yeah, distributivity. Right, yeah, okay. All right, so distributivity, or the distributive property connects addition and multiplication, showing how to distribute multiplication over addition. right? This one here is one that we'll use a lot when it comes to algebra. This is used a lot in algebra, especially when you're doing things like factorization. That this comes back up a lot. So what does this mean? Um, let's do a quick example of this. So like if you have a number multiplied by the sum of two numbers, let's say b plus c, then this is equivalent to saying a times b plus a times c. So that's the equivalent of it. Sometimes what they tend to do is they tend to write it like this: a into b plus c, and that's what you see in most of your algebra work. But all it means is we take a and multiply it by b, and then we take a and multiply it by c, and then we use the operator in the middle. So let's say let's do a quick example of that. Like let's say 2 into 3 plus 4. You can see I can just tell I just put 2, 3, 4 as the result. What we're saying is that this is equivalent to saying 2 times 3 plus 2 times 4, right? And if I work out both sides, you would see I'm getting the exact same answer. So apply BODMAS or PEMDAS. I work out the brackets first. The brackets inside of here is 7. And then 2 into 7, I get 14, right? And then when I look at the other side as well, now I can see 2 times 3 is 6, and then 4 times 2 is 8. So 6 plus 8 is going to be 14 as well. So that is the distributive property, right? This is one, as I said, we use it a lot when it comes to algebra. And these are all the properties I need you to know about. Once you know these properties, when we move on to topics like algebra or solving for x or doing anything that working with numbers or operators, you'd be able to use these properties to help you solve the problem.